I would just like to say we are now leaving linear algebra, okay? No more linear algebra. It's not going to help. It's not going to be helpful to us. We can't use it anymore, all right? Now, let's go. So we have AE, AF. Let's make this bigger. Hopefully that's like legible to everybody. That's the first matrix, and that's A Kronecker product B. And now we're gonna set it equal to B Kronecker product A. Fuck. I don't know how long I've been muted. Okay, it's okay, everybody. I realized I muted the mic and I freaked out, but I checked it and it was at a fine time, so don't worry. Continuing. So basically all I did was draw out these matrices. That was all I lost. So I drew out these matrices. And so basically we need these two. We have this product. We have this product A and B, and we have this product B and A, right? And for AB to equal BA, what really needs to be true is all 16 entries in each place must be equal to each other. So instead of two things equaling each other, it's 32 things equaling each other. But don't worry, because we're going to use our problem solving skills and our pattern recognition skills and things of that variety, okay? We're going to come out on top. This is not as big of an issue as you think it is. It seems like a lot, but don't worry about it. All right? I'm going to walk you through it gently. That's what's going to happen. So we got to take it from the top. That's all we can do. All right? Let's get rad involved. Yeah. So this number must equal this number. Because remember, A, B, C, D, E, F, G, they're all numbers. Okay? That's the nice thing. But we don't have to worry about the numbers right now, which is why we're going to recognize a pattern, which is what's cool about math, everybody. So just everybody hold their horses. That's what I say. So those two things would have to be equal to each other. So that means A. All right, let's not. I don't love that color, you know. These are customizable and I still hate them. But anyway, A, E equals A, E. Now, that seems dumb, but that's important, okay? That's kind of a thing. Things that seem stupid like that are going to become more, like, make more of a difference than you would want to believe, okay? Because check out what happens next, okay? So we have this number has to equal this number, okay? So writing that out, that's A F equals B E, okay? And then just when you thought this was getting boring, this does kind of get interesting, because so the next thing we gotta do, obviously, is make sure this equals this. Okay, writing that out again, we have BE equals AF. But now we run into something interesting, folks, because we've already written, it's already been said that AF equals BE. So now we're saying BE equals AF. Same thing. They're equal to each other. Okay. So this gives us like a hint. But we do have to keep going. But this is going to give us a hint as to what we might be able to do with it. Like maybe we can simplify this and it's not so purposeless after all. So, because we know that whatever AF is whatever BE is, which is also going to be what all of those entries are going to be. They're all the same, like they're all equal to each other. It's great. So, continuing, BF equals BF. Well, that's an easy one. That's another one of those. That's actually similar to AE equals AE, right? Okay, so that's actually, you know, this seems really, we have two equations so far, you know what I mean? So, okay, next, AG equals CE, we have AH equals DE, and then we just did these pairs, right? But then, if we look at this pair next, we will get another CE equals AG. And also because this is normal multiplication, GA equals AG. That's not a given, but I should have said that. So just to clarify, that is true. Like that is an assumption. But we have a pair of similar equations again, folks. And then if we look at these two, this pair, BG, okay, we get another CF, BG. So we can simplify that again. And then actually if you look here, oh man, this is getting messy. AH, DE, AH, DE. So I feel like you can kind of see what's happening here. Like I'm gonna do the rest of this out without commentary, and then I'm gonna come back to you with a kind of simplified situation. But I feel like you can kind of start to sense the pattern here, where you just kind of match things up and you notice that they are repeats of each other, essentially. You just pick up on the repeats, and then so the next step here is literally just to pick up on the repeats and simplify it from 16 equations to hopefully less than 16 equations, right? So I'm going to write that out a little bit, and I'll be back in a second. Also note that this entry, and this entry, and this entry, and this entry all have to be the same. That is the pair DFBH, and they're equal to each other. Okay, so that's all the pairs. Again, here's another one. Here's another one that's the same. That's a pair that's itself. That's a pair that's itself. BH, DF, we talked about this pair. We now simplify this to, let's simplify this down to less equations. So we have we have AE equals AE. So we're just going to call AE a fundamental pair. Okay, we'll put it in red. Now also if we look at this, we've got C, the corners are fundamental pairs. So, you know, we have this matrix, we just take a look at one of the original matrices, okay? The four corners are these fundamental pairs that will always equal themselves, okay? So we're gonna set those aside. And those are AE, BF, CG, and DH. Okay, and we want to we are going to, so like a video game, the fact that this equals itself is kind of a glitch in the matrix, if you will, because we're working with matrices. But this is kind of a glitch that we're going to exploit / use to our advantage coming up, is these fundamental pairs. We are going to take advantage of the fact that these always equal themselves. That's going to be helpful to us, all right? In the way, I'm sure there are other ways to go about solving this problem, but in the way that we're solving this problem, we are going to use that to our advantage. So the next thing we'll do is take note of we're just going to now list the rest of the equations. And the fun thing about this is in all of these setting things equal to each other, we have nothing without a duplicate. There's everything has a duplicate somewhere. So this simplifies nicely. So we have these four fundamental pairs, which are, you know, the four corners, and then our other kind of fundamental equations, if you will, and I may, are AF equals BE, DF equals BH, AG equals CE, DG equals CH, DE equals AH, and BG equals CF. Okay, so the next thing to notice here, that when I was trying to solve this problem, the next thing I noticed is that we have AE equals AE, okay? And then we have these equations. And if you'll notice, you can't find an equation with an a that does not also have an e on the other side. And like, isn't that why? Like, isn't that weird? Isn't that interesting? Like clearly, like because I don't know what it, like, I'm not being like, but like him and Han or whatever they say. But like, isn't that kind of interesting? Like, this isn't set up. This is what I was doing, and I noticed this, where like you can't find any A's without an E. And likewise, like, you can't find an F without a B, right? You can't find a C without a G. And then D and H. They're all fundamental pairs. You know what I mean? So the next question is like, what do we do with this? Because this is great, but like, what do you do? As I was working through the problem, my vote was to simplify it. Okay. The next thing I thought about was like, if I can throw a 0 in, if I can set something equal to 0, right, that might eliminate some things and simplify this down even more. All right. So that's what we're going to do next. We're just going to throw a 0 in. Maybe make this another part, Adam? I don't know.